So first of all, my name is Pat McCurdy. At Phoenix Contact, I lead our industry management and automation team for the US. And it's wonderful to see everybody and be at an in-person event again. I've had a few in the last months, and it's just really exciting to be face-to-face again with colleagues and in our community and in our network. And you can really feel, I think my experience is kind of the energy in the room. And so hopefully we'll continue that energy with our lunchtime workshop today on the Coalition of Open Process Automation's Quick Start Guide with an active demo in a few minutes. Before we jump to that, I wanted to just give a little introduction to Phoenix Contact in case someone here does not know us. However, if you do know us, you likely know us from something that goes inside a control cabinet. Or you might also know us from the little green connectors that are often found on industrial control equipment. That's one of our early product innovations, and to be completely open, that's one of our bread and butter products that has been a success for our company for many years. But inside the control cabinet, we offer a lot of different product lines and product areas, starting with power reliability. And certainly those of you here from the process industry, I'm sure have seen our Quint Power one time or another, but we also have surge protection products that fit into that portfolio of products, as well as circuit protection. We also have a control product which will be highlighted today called PLC Next, and we have in fact a whole family of I/O, IPCs, HMIs. Connectivity is an important part of our DNA, as I mentioned. The DIN rail mount terminal block is something our company invented 99 years ago. Next year will be our 100th year in business, and that was how we got started. Shop floor productivity is an area we've invested a lot in. If you have panel shops or frequent panel shops, you'll often see our markers and printers and so forth sitting in the back rooms. Networking has been a big growth area for us in the last 20 years, from unmanaged infrastructure all the way up to layer 3 switches. And then secure remote connectivity is also an important part of our automation portfolio, which includes VPNs, connectivity products that allow you to make secure remote connections to your equipment and your facilities. And then last but not least, safety is an important part of our portfolio as well. The full line of safety interface products, also a small safety controller. We also have the ability to run ProfiSafe and other safe certified safety applications on our PLCs. Just one step further, and I think I highlighted most of these things, but this is really what we consider our automation portfolio. If you take one step down from the full control cabinet suite of product offers, then we go down into our automation products, which I've already mentioned. In terms of markets, Phoenix Contact is really a broad market company, and due to our DNA of connectivity and connection products, that's taken us into really a lot of fields, business to business areas, including solar, including wind. We're one of the premier control providers to the wind industry. I would almost guarantee any wind turbine that is in an installed base in the US, if you open a control cabinet, it will have Phoenix Contact inside. Factory automation, that's been a big important market for us in the automotive areas for many, many years. Transportation, telecommunications, building automation, and so forth. This says audio. It's not playing audio. I'll go back. There we go. So PLC Next is a technology that we introduced to the US market in 2020. PLC, as the preface is a little bit deceiving because it's actually really a lot more than a PLC. First and foremost, it's a Linux-based control platform that is open, secure, interoperable, reliable, and scalable. Second, it's IIoT ready. So many applications for Industry 4.0 digitalization require the collection of data and the transportation and manipulation of that data, and also the transportation of that data up to a cloud service. PLC Next is a platform that's ready for that kind of connectivity. We have an easy to install app that allows, really any customer almost at any technical skill level to collect data and take it to Amazon, AWS, Azure, or even our own cloud service called Profi Cloud. And can be done in a very easy to handle, configurable manner. So that's the second thing. Thirdly, the way we describe PLC Next is it's a PLC reimagined. So it is a PLC. We have our own runtime called PLC Next Engineer. It's 61131 runtime. However, what we've learned is that customers are more often today asking for the ability to run higher level language. As demographics change in their workforce, there's a desire and a need to provide a programming environment that's based on more high level language programming. So you can do C++, Python, any high level language can be also programmed on PLC Next. So in addition to 61131 programming, you have other options. So that brings us a little bit to why we're here. We often ask our customer the question, what is your control system not doing for you today that you wish it would? And many times the answer to that will lead us down a path where the discussion is open. And specifically for this community in the process industry, we found that open process automation and OPAS really is a good fit for Phoenix Contact with PLC Next. So today we're going to do a demonstration with the coalition partners that we've assembled today. I'm going to turn it over now to Bob Hagenow of Seaplane, the CEO of Seaplane, and he's going to get us started on the COPA Quick Start demonstration. Thanks, everyone.
Pat, first of all, I want to thank you and thank Phoenix Contact. They've been a founding member of COPA since the beginning, and they've been very involved, committed a lot, and they provide some of the mission-critical kind of best-of-breed components within what we're going to demonstrate today. So we really appreciate their partnership. My name is Bob Hagenow. I am the CEO of Seaplane.ai, and Seaplane.ai, each one of the members of COPA brings something to the table, typically a best-of-breed component to the table. What we bring is systems management and orchestration that helps kind of provide the glue that holds the system together. But let me talk a little bit, let me see if I can get this working, talk a little bit about what is COPA and why did we form COPA. Last year, version 2.1 of the standard came out, which was the first version of the standard that you could actually build an operational system to. And Don and I started hearing from end users questions like, our executives are bought into open process automation. They really believe in the benefits of open process automation. Where do we buy one? And the reality was that there was no place to buy one. And there's a couple reasons for that. One is that a lot of the end users didn't have the deep pockets and the deep technical, or I should say the deep technical and process automation expertise that ExxonMobil had. So they really couldn't go down the path of ExxonMobil, and they needed somebody who they could buy a system from. And the reality was that an open process automation, by definition, is a multi-vendor system. And so, we realized that, hey, we need to kind of form an ecosystem of companies that are interested to have, like Phoenix Contact, have kind of best-of-breed components in an open system and bring those together with other vendors that bring other components. And so we assembled a team of now up to 14 vendors that are all contributing technology into the open process automation system that we're going to demonstrate today. Now we also have systems integrators in there. CSI is kind of a a deep specialist in open process automation, and that's led by Don Bartusiak. But we also have an SI Wood. Wood announced this last week that they are creating a center of excellence around open process automation, and specifically around COPA technology and the COPA coalition. So that's a critical step forward, because a lot of the questions we hear oftentimes from end users is, who's going to be responsible for the performance of this system if I've got a multi-vendor system? And Wood is saying, we want to be that person to you guys. We want to take responsibility for the performance of the system and play a lot of the roles that the DCS vendors have played in the past. So having them announce that this week was significant. So I'm going to kind of finish talking here because we want to get into the demo, and I'm going to have Don Bartusiak I'm going to invite him up to do the next part of the demo.
Folks, I'm going to go down on the floor because this is going to be real show and tell. So what is the COPA Quick Start system? So it's a small, fully functioning control system. Its purpose, its fitness for purpose is as a training and learning device. But the offering, the market offering, also includes a training program. So it's intended to be an affordable entry point for customers to get started assimilating the OPA technology. So I'm going to use the chart here. Everyone, I think, is familiar with the OPA reference architecture, and I'm going to point to the reference architecture and then point to the COPA rack to connect the dots between what you see functionally in the reference architecture and what's manifested physically on the COPA rack itself. So let's start. I'm going to highlight. I'll come over here first just to point. I didn't bring my pointer with me. We're going to talk about DCN, distributed control node, the I/O profile. So that would be an example of this node in the reference architecture. We're going to talk about distributed compute node, DCN compute devices, that they themselves don't have field device I/O. They communicate through the OPAS connectivity framework, the OCF. And then the other thing that's prominent that I'm going to talk about is the Advanced Computing Platform, acronym ACP. Okay, so they're the basic principles. Now let's talk about the physical realization. So at the bottom of the rack here, this represents the process, the field device. Okay, so in the Quick Start system, this is hardware and software from a Canadian company called VP Process. We have a dynamic simulation of a process running in a Raspberry Pi, and analog input and analog output cards generating, writing or receiving 4 to 20 milliamp signals. So we have a representation of real I/O. That's the bottom of the rack. The next three rails are the I/O functions. Hardware from the products from two suppliers, Phoenix Contact and Stahl. This side of the rail are the I/O modules themselves in both the Phoenix Contact and the Stahl case. At my right, your left end of the rail are the PLC Next devices in the case of Phoenix Contact and a Stahl CPU node. And in these nodes is where we're running the OPCUA servers that produce the OPAS signals. Okay, so OPAS signals are an OPCUA data type that is specified in the OPAS standard. Okay, so we've established a known interface to data with the OPAS standard. And so the data are transmitted to the OCF. So this part of the rack is the networking gear, the Cisco switch here, that is communicating the OPAS signals into the distributed control node compute devices. So for the DCN computes, we actually have 9 of them in this rack. There's 5 from ASRock Industrial, 3 from VCal, and there's 1 from Phoenix Contact here. So these are all, basically we're doing the regulatory control and other functions that I'll highlight in a minute in these DCN compute devices. Let's see. And this is primarily, essentially all real-time, Linux with real-time extensions running in these devices. Had to do Windows. The ACP is realized with Supermicro servers here at the top. So I said we're running the regulatory controls that I'm going to demonstrate in a minute are running in the DCN computes. We're going to show that we're running a CSI product, a model predictive control software product, running in these DCN compute devices. These are commodity IPCs. Okay, and then again, the ACP, where we're doing the systems management functions, the HMI, historian, alarming types of functions are being run in the ACP, and at the top is just a top of rack switch. So that's a walkthrough of the system itself, and if we can. Well, I don't want to. You want to start with the MPC or? Yeah, we. I want a corollary to Murphy's Law. Murphy was an optimist. So we actually came prepared with a UPS. And when we brought the rack over from the showcase room, we had the UPS powered, and then when we moved it to here, we connected to an unenergized extension cord. And so we actually lost the unit. The unit powered down, so I don't know if we're going to get the live demo back. Okay, perfect. So I'm going to be able to show you some of what we hope to demonstrate live. So thank you for your patience and forbearance. But let me verbalize, not to have dead air. So the process unit that we've got simulated in the quick start system is a fired heater. So what I'm going to show you is basically 3 tiers of control strategies, just basic PID control for flow rates of 2 process streams and 1 fuel gas stream into the heater. Okay, the second tier of controls is advanced regulatory control implemented in the form of, cascades of PIDs and selectors. So this is something that would be very customary in any one of your DCSs. And the third tier of control, and that one I knew I was only going to do by video, again, is the CSI model predictive control product. So if we can get, what I'm waiting to see here is the inductive automation HMI. I'm going to talk from that. Okay. So does anybody have any questions at this point? I don't want to get ahead of ourselves in the story. Any questions or comments from y'all? Sorry? Yeah, okay. Bob is suggesting, let's talk about how we actually built this. COPA, we've been asked this a lot this week. What is COPA? Is it a trade association? Is it a dues-paying collection of companies? It's not. Okay, this is a voluntary coalition of the willing, companies that wanted to come together and work with us to produce an OPAS aligned system. So the cost of entry, if there was any one, is the development effort that the partner companies put into making this work in practice. Okay, so I do vividly remember when ExxonMobil started with our proof of concept system back in, geez, Dave, what was it, 2016? I mean, just getting OPC UA to work was a major challenge. And what was, I can tell you, fast forwarding to, let's say a year ago to when we started building this, it was astonishing to me how much easier it was to assemble these components when the suppliers brought instances of OPC-UA clients and servers that actually worked reasonably well. That was a really, really pleasant surprise. And I see Vien nodding his head here. Sounds like the Yokogawa team has had similar experiences. Okay, so that's a really positive development. And so the work that we did in development, I mean, the first thing with OPC-UA, if you're doing that work, well, you know, if you can just get the value communicated, that scalar piece of data, it's like, woohoo, woohoo. We're well beyond that now, okay? So we're actually communicating, you know, the OPAS analog signals, which is a fairly big package of data, okay? And that's actually working in practice. Similarly with Codesys is what we're using for the regulatory controls, and we are literally using the OPAS Part 6.4 function blocks, basically for everything you're going to see here. So that's Codesys software written by, configured by Nova Smart. So there are other contributions from the contributors, the COPA members. So we do have a, Dave? Yeah. Well, we would certainly want to communicate it securely to the network so that we can support the customer remotely. I mean, we would certainly do that. But let me talk a little bit about the training program that we're going to offer. Bob, unless you were going to go into that. I can start verbalizing that. So this is what we're offering to the customers. And this is, we adapted this based on feedback from our customers. We have 3 tiers of training. The first tier is a 2-hour overview it's targeted towards basically to get the management level bought in, to understand. It's a 2-hour session. That's the first experience of the training. The second package of training is a 2-day, more in-depth overview of the whole training package that we're going to offer. So that is targeted for, let's say, like mid-management and the engineers who are going to be participating in the training. And then the third of the 3 packages of training that we're offering is approximately 50 hours of lectures and hands-on labs with the system. So that 50 hours, it constitutes, you know, the things that an applications and systems engineers would do on a project, right? So it's, you know, how do you configure a system? Actually, we're going to get into how do you spec a system, how do you procure, how do you evaluate components. You know, we're going to cover all of that territory. Then, you know, how we're going to go through like a mini project. Okay, we're going to have a design case. We'll probably work against this fired heater. So you got to name tags. You have to, you know. So how do you label wires? Not going into great detail, but the whole experience of a project. How do you provision a system? You know, IP addressing, things of that nature. You know, we're gonna show how the OPC-UA configurations get done, communicating among all of the component parts of the system. You know, how do you implement the security aspects? Okay, so you're not going to just accept anonymous logins. We're going to show them. You know, you got to authenticate that signal. If you want, you can encrypt it, but God Almighty, you got to authenticate it. So the users will experience that. And then we'll get into some basic, you know, just basic control strategy building. So that, you know, we'll show, you know, okay, so just design a couple of PIDs, and we want to dialogue with the clients. Well, how would you guys approach, you know, give them the business problem, but not give them the answers. You know, what kind of controls would you like to build? Build them for them. Build the HMI. do all the OPC-UA connections, set up the alarming, how do you configure the historian? That whole process, that whole project experience is what we want to get. Then we're going to push into the operate and maintain life period of a system. How do you do software installs? How do you do patches? How do you do updates? Okay. We're going to demonstrate how we're going to be delivering high availability with software-defined means rather than physical pairwise redundancy. So I've just kind of off the cuff going through most of the table of contents of the training curriculum. Okay. Anybody else? Susan? I'm sorry, I'm getting like every other word.
So I heard you talk about 6.4, part 6.4. What other profiles have you been aligning to? Is it OSM 001 or is that?
I'll have a slide on that, but I can take that one on. Yeah, so everything that we've done here, so OPC-UA, it's OCP 001. We only have client server in here. I'll talk about futures maybe towards the end of my remarks. We only have OPC-UA client server, so that would be one. So I mean the network profiles, I think, we have the network profiles covered, so with time synchronization. I don't anticipate that. Certainly will satisfy all the cybersecurity facets that are required of the components in this system. In fact, let me digress a bit. Because of the open nature of this OPAS-based system, we've actually been able to incorporate cybersecurity technologies that go beyond what's discussed in 62443. If any of you saw our second showcase event, which we presented about, I don't know, a month, 6 weeks ago, what we showed actually was Intel technology, has the verbal title remote attestation. So that involves having TPM chips in the node itself that take a signature of a device as it's configured. And if any unauthorized change to that device occurs, okay, the signature of that device changes, so that your system management provisions, it's probably going to be the orchestrator, can detect when an unauthorized change to a node has occurred, and then the operator, I mean the operator of the system is given an alert, an alarm, that calls that to his attention and asks the operator of the system, what do you want to do? Do you want to move the workloads on that node? Do you want to just quarantine that node? Do you want to shut it down? Okay, and we demonstrated that, again, that capability. You can see the videotape at explore.copacontrol.org. So Susan, that's an example of where we're going beyond what's in the OPAS spec. Okay? Is there a question?
Is this in use anywhere physically in the world in production? And if so, can you speak to where? And if not, do you have anything in the pipeline, or do you have any visibility on when this might be hitting the ground?
Okay, so this is our third build. Okay, our third build. It has not been used in production anywhere, and that was not really the intent of this configuration. But the plan is to work with our customers to use this as a basis to engage with the customer to start talking about what do you want to do in terms of a field trial or even moving into production. So what we would do, this is our kind of notional design for a 200 IO unit. This unit maybe, if we doubled the simulator backplane capacity, I mean, maybe we have 60 IO. This is notionally what we think a 200 IO unit would look like, probably 2 racks of this size. And this is a notional layout of the nodes that you see here, of the devices that you see here. And this would be the basis for something that we would do on process. But the direct answer to your question is we have not gone on process with this equipment yet. Okay?
So we packaged the product to what the users have told us how they want to adopt the technology. So we want to get our hands on it, we want to learn about it, we want to understand it, and then move into a field trial, control, and then move into full production. And so that's how we've packaged it here. So that's why you're seeing this unit initially. However, the architecture is such that it can expand to whatever size of IO you want. Now, this is just a 200 IO, but you could have a field trial that would be much larger than this as well. But the idea is, let's get you understanding this and answer your questions about it, and then you can move down the step of production. Now, over time, maybe in 2-3 years, some of the companies, as they call it, the majority adopters, may jump right past the learning phase and go directly into production. But at this stage, that's not the case. One other thing, again, so this would be included in the training is going to be a workshop that CSI will lead that will help you understand and pick kind of what is the project you want to do for your field trial. But then we'll work with a systems integrator of your choice, or Wood, because Wood will have a center of excellence built around this, so they could actually be your systems integrator as you start to move into the production phase, because we know that that's going to be important for you. Brandon, how are we looking? Is there another question?
Yeah. Hey, Drew Ainscow from Chevron. So I know that you guys are putting this system together, and it's supposed to be like the pretty package that everybody can say, wow, look at how amazing this is all together, right? I kind of wanted to hear, what were the learnings that you got from putting this system together? What were the pain points that we might expect as end users as we start to implement this that we should be thinking about? Not necessarily for the next versionings, but what were the things that you didn't think were going to be problems until they were problems?
Yeah, I would say, Drew, it's the thing I said first. I mean, everybody's got, I would say that it's common now for people to have basic OPC UA capability. But when you actually have to exchange a more sophisticated type information, that package of data and setting up the OPC UA information models requires more than just basic familiarity with OPC UA. So that was one learning. I see Stefan's shaking his head back there. But again, it was a heck of a lot easier now than it was a few years ago. I'm genuinely true. So that was one learning. I think the Redfish systems management technology that is new, this has been discussed this week, that's new to the OT supplier community, was something that took some time for the suppliers to get into their products, which is one of the reasons why we picked, that was one of our selection criteria for the devices that we picked. I would say that was a learning. What else? What were the big ticket items? I guess there were learnings. The regulatory control software that we're using in Codesys is, not fully built out. There were quite a bit of learnings. Improving on the basic software that's in the OPAS Part 6.4 standard. So that would be a category of learning I would cite as well.
But I would say our goal is to take a lot of the challenges that Don just said and make those our challenges, not your challenges, right?
Right.
Seaplane is acting as a subsystems integrator to bring a lot of these technologies together and work on the engineering level with all of these vendors and suppliers to make sure that as we take it from paper to actual breathing a breathing live system, that the things that we're talking about here have all been taken care of. So But there is going to be, a hardening season of, these are new technologies that will need to, really mature for a bit. Though those are maturing quickly. So we're working with the suppliers on all of that. But we're hoping to take all of that off of your plate, and CSI and Seaplane and the COPA partners will have all of those problems hopefully solved for you. Now, I'm sure there's going to be other problems, but that's our desire. Okay, let's see. Where are we,
So
Brandon?
hopefully. Yeah, so honestly, what I'm going to display here in the room is what we've been displaying in the showcase room, starting from Monday night. So it
All
looks
right,
like- looks like-
it's running. So
looks like-
we've had a remote. Our CTO is working in the background
Yeah,
from
but you
San
have to- you have
Francisco
to be in
to actually
the,
get the system back up and booted and
Right.
reconfigured. So
Oh, he
that's
did everything?
what's been happening here.
Yeah, so we're perfect. No, that's Dakota system. Let me just I only have time to go to ignition. Okay, super, guys. Okay, thanks. Back in the game. Okay, so I'm going to be brief now because we've chewed up a lot of time with the technical problems. So this is the fired heater. This is the base flow control schematic. So I'm going to get into application speak, but only for the purposes of illustration. So you kind of have three control objectives on this unit. You want to control the coil outlet temperature. You'd like to control, but ideally maximize the throughput of the process stream. And then the third objective of a unit like this is you have to be careful not to violate tube skin temperature constraints. Okay, so this is just, as I said before, these are just the three basic flow controllers, one on each pass, process pass, and then a flow controller for the fuel gas. So that's where you start. That's basic controls. I mean, Brandon can. Yeah, just to show you guys that this is real stuff. Brandon, let me come up there. So we're gonna change a set point. You're gonna see the numbers change. This isn't just white noise.
I just want to point out it is 5 after 1, and I apologize for how we've run over. We're going to continue this. There's no other sessions in this room, so we'd love to have you stay with us. But if there's other sessions you want to go to, totally understand. And we appreciate your patience with all of this. So.
Okay, so with that set point change to one of the pass flow controllers, you can see that the controller output changed, the throughput on pass 1 changed, the coil outlet temperature is going up a little bit. Brandon, if you can click the outlet and tube skin temperature control tab.
That's here?
No, it's you see the frame on the left? Outlet and tube skin temperature. Yeah. Okay, so we don't have time to illustrate this, but the point I wanted to make is that second tier of controls capability that you would typically do on a real unit is to build a traditional multivariable constraint control application for the purpose of controlling the coil outlet temperature, satisfying constraints on the tube skin temperatures. And if I had time, we would have set this up to show you like a fuel gas flow change, because you want to raise the temperature. The tube skin temperatures would be violated. The constraint controllers through the selectors would kick in, and you'd see how slow it is, this type of control strategy to respond to that type of disturbance. And the third thing that any customer would get with the Quick Start system is going to be the CSI Model Predictive Control product. So for that demonstration, we're just going to roll maybe 2.5 minutes of tape. Okay, and that'll complete my part of the demonstration. Okay, so bear with it. 2.5 minutes of
show you
video.
is that model predictive control can resolve that in a much more effective way. And that's what we're going to do right now. We'll do the same experiment.
So this is CSI
model predictive
CTO
control
Tom
is running.
Badgewell.
And I'm going to change the outlet temperature set point up to 790. Very carefully. And so what we're seeing here is the red line is current time. And so here's my set point change. And the controller is predicting this is what's going to happen in the future to the outlet temperature. It also says that the tube skin temperature is going to briefly go above this limit and come back down. But it's not going to go so high that it alarms. Before we saw the alarm go off, right? So before the alarm happens, the controller brings the tube skin temperature back down, and now it's going to ride this limit for a little while in the future. And it also says that it's going to bring the outlet temperature up to its set point. And the way it's going to do that is to back feed out of the heater. So we're going to give up on our feed set point so that we can achieve our outlet temperature set point. And that's the priority that we programmed into the controller. And so this is the real value of model predictive control. You can set up priorities. You can respect constraints in a much more effective way. And with other types of applications, pretty much any MPC that I've implemented in a refinery, you can increase the throughput to the refinery by a tiny amount, say 0.5%, and you'll make millions, multiple millions of dollars a year. So this is very effective control technology, and it's great to have a system, finally have a kind of system where we can experiment with new technology in this way and implement MPC at the edge.
Great, let's cut it there. Thank you. Let's cut it there. Okay, so I want to close with I have one slide, then I'll turn it over to Brandon. And our customers are asking us to what extent is there alignment or conformance. We can't use the phrase conformance yet, but what's the status of Quick Start against the OPAS specification? So who's got the slides? Can you advance a couple? Can you get to mine? That's good. But go back. That's one back there, Pat. Okay, so this is just the table, the OPAS table of contents with some forward look here into parts 8 and 9. So again, we conform to the technical architecture. We have all of the cybersecurity facets that would be required today. OPC-UA is used extensively, as I described. We have Redfish in this system. We're using IEC 61131 language that I cited with Codesys, again with software written by SMAR. Looking ahead, now we can't say that we're conforming to where the forum is headed with physical platform work and where focus is going with PICWIG as the standards basis, but I can tell you that the Quick Start system already makes extensive use of containment for how we're delivering the software modules. And again, Tosca-based orchestration, again, is Seaplane's core contribution. So this is what you're going to get in the Quick Start system today, and I'll leave it at that.